Okay, so good morning to everyone. Now, in the last class of our the cryptography of in me part, that which part I am taking, in that part I have last discussed about the Diffie-Hellman key exchange. So what is the Diffie-Hellman key exchange we have seen, and why the cryptography why it is used, if the cryptography is hard enough, and the cryptography is totally the not answer, because most attacks do not about to involve breaking of encryption. We have already discussed about that. Now today we will start discussing from the firewall concept. So basically, starting the concept, the firewall, we will know what is the firewall. Now, firewall is a system of hardware and software components that is designed to restrict the access between among the networks. That means it will be, let's say, there will be the networks, public network and the private network. So that is when our Google we have searched, that is the public network. And let's say in the LAN there are the systems connected. So between that, from a public network, between the public network and the private network, we uses the firewall. Now why firewall is used? Firewall is used to restrict the design. It is restrict access between among the networks to most often between the public and private network to restrict the access. And firewall is a part of overall security. It is related to security policy that creates the perimeter defense designed to protect the information resource of the organization. So it will be used between what? It will be used between the public and private network, and it will restrict the access of some malicious packets. Let's say some malicious packets is coming from the public network to private network. So firewall will do what? It will restrict that access. So it will use some its problem. It will see it, and after that it will do what? It will restrict the access. So if some malicious activity is occurring, then the firewall will be responsible to restrict that. So firewall is related to the security policy, and it creates the perimeter defense design to protect the information resource of the organization. Now, what firewalls basically do? Now we say that firewall is from public to private network. Between them, the firewall we are using to restrict the access of malicious activity. But what basically the firewalls do? Now, basically the firewalls implement the security policy at a single point. So at that point, so the point from where we are connecting the public and private network, in that point, the firewall is placed. So it will implement there for security policies, and it will what? It will do what? It will monitor the security related events. Now what it will do, the security related events, that means it will check the log file. That means, let's say, between the public and private network, from private network, which packet is going there in the public network, then from public network, which packet is coming in the private network. So all of this log, that means what are the events occurred between them, that will be monitored by this firewall. So it will monitor what? It will monitor that log file. So it will monitor that log file to see that any malicious activity happened or not, or any packet which is malicious is entering into our system from the public network. So that will be seen by the firewall. So it will track the activity. It will see all of the logs to related events which is happening. It will monitor that. To monitoring it, if it see any malicious things, then it will stop that. That's why it is used for monitoring the security related events. Then it provides a strong authentication. So the strong authentication we have already seen, the authentication problem. That means, let's say two sender, there is a sender and receiver, and sender will do what? Sender will send a packet. Sender will send the packet in the unsecured channel. It will send the in the unsecured channel, and it will do what? Authentication. For authentication, it will encrypt with the private key. So encrypt with the public key of intending receiver, so that in that case, let's say A and B, there are two person present. So A will do what? It will encrypt the message using B's public key, so that B will able to encrypt that message only. This is the thing. So it is providing that strong authentication here also. And it will allows the virtual private network. So it will allow virtual VPN, which we have already seen in our network, that the virtual private network will be used, and specifically hardened or secured operating system. So securing the operating system, there is specifically hardened and secured operating system is present. Now, the firewall, we have seen that these things the firewall do, but completely firewall will not able to restrict that. Now, in which cases the firewall will not able to restrict? The firewall will not able to restrict for protection against that attacks that bypass the firewall. In some time, the attacks that bypass the firewall will not able to solve that. It's like the problem of dial out from the internal host to the internet service provider, or some internal threats. That means some problem, some malicious activity that is occurring inside the internal network, because firewall is placed where? Firewall is placed between the internal network and the external network, or public network or private network. Between them, the firewall is placed. Now, if anything is happening, and firewall is there to see that any malicious packet is entering into the private network, or any malicious packet is going from private to public, or from public network to private, any malicious packet wanting to enter, that is seen by the firewall basically. That's why it is placed between the public and private network. But if the malicious activity is going inside, let's say the malicious activity is occurring inside the private network, inside it, so there will be what? There will be no protection for that. There will be the no protection for that. Firewall will not able to solve that problem, because the problem is occurring inside. So how it will do that? How it will protect in this internal threat? It is not possible for the firewall to do that anything in that case. Like if insider cooperates with the external attackers, that means insider inside the systems that are present, that they are cooperating with the external attacker. In that case, the internal threats are there. So if there is an internal threats occurring, firewall will not able to handle that. And it only protect, because why it will not do? Because it will only protect against the transfer of virus infected program or files. That means it will see the transfer, only that there is a packet entering or the packet is going outside, because it will see over that virus infected files came from outside, or the virus infected file is going to the outside network. So it will only do that. It will only check that. But if any internal problem happens, then we cannot use the firewall. So this is a disadvantage of the firewall. Now, there are 4 types of firewall present, that we say packet filtering router. This will check that what packet is entering. If the packet is malicious, then it will stop it. And if there is no malicious, then it will say that from outer network that the packet can reach to our destination. Then application level gateway, this is also related to that, and circuit level gateway, hybrid firewalls. So all of these are the types of firewalls. But basically the packet filtering router or the packet filtering firewall we are used that by seeing that which packet is entering there, this firewall will do to check that. And so this is related to our firewall, and we have 4 types of firewall, but basically the packet filtering firewall is basically used, and this application level gateway, circuit level gateway, hybrid firewalls, it will do what? It will basically do what? It will basically hide the IP addresses of the system that is present in the internal network to the outside world. So why they will do that? They will hide the IP addresses of the system that is present inside the internal network to the outside world. So that's why, that is basically that from outside any attack happen, then that particular IP address the attacker doesn't found, so that in that particular system it can attack. So that's why it will hide the portion from the outside world, hide the IP address, so that the directly in that system the attacker will attack, it will not happen. But that is what we have already seen, that if internal problem happens, then firewall cannot do anything, or if their internal system are cooperating with the attackers, so that then it will create confusion and the firewall will not able to restrict that problem. So this is the basic thing of the firewall. Then next is the IP security, the IPsec, or we say IP security. So IP security is what? It is the collection of protocol. It is the collection of protocol used to create the VPN, used to create the virtual private network. We say it is used to create the virtual private network. Then a network layer is there. So a network layer protocol providing the cryptography. This IP security is basically what? It is the standard suite of protocols. We say this is the standard suite of protocols between the communication point across the IP network that provide, this IP network will provide what? This will provide the authentication. This provide the authentication, integrity and confidentiality. This will provide, and it also defines the encrypted and decrypted authenticate packets. Now we cannot support authentication from two ends of the tunnel. Now the tunneling happens when? If you remember, the tunneling happens, I have discussed in the computer network, the tunneling between the IPv4 to IPv6. Because in our till now, all of those systems do not use the IPv6 concept. Subsystems will use the IPv4 also. So between them normalization, we use the tunneling concept. So tunneling, authentication of these two ends of the tunnel, it provides, this IP security provides. This IP security provides the authentication from the two ends of the tunnel and cannot directly encrypt the non-IP traffic. So that if a non-IP traffic comes, it cannot directly encrypt that. It cannot directly encrypt that. Now, what are the uses of the IP security? So why we will use the IP security? Now, basically, we will use the IP security to encrypt the application layer data. So the topmost level of the OSI, what is the topmost level? The application layer. So basically, to encrypt the application layer data, we use our IP security. And also, it is what it provides. It provides the security for routers sending the routing data across the public internet. That means it router sending its security for the routers. It will see the security for the routers to sending routing data across the public internet. And also the uses of it is what? It will provide the authentication. Without encryption, it will provide the authentication. Now, like authentication have, like what type of authentication? Like to authenticate that the data originates from a known sender. Now, we have already seen that if there is in the before the symmetric key exchange in there, if I am thinking as a receiver that yes, the message is coming from the intended sender only, that the sender in this particular, from that particular sender only the data is coming, that intended, we say that intended, that data is coming from there. In that case, the data we would do what? We will send authentication without encryption. Without encryption, this will provide the authentication. This cybersecurity will provide the authentication. And to protect the network data, by setting the circuits using the IPsec tunneling. That is why, because all the data is being sent between two endpoints is encrypted. That means the data that should be sent and the data from that in the other end will be what? Will be the two endpoints. In that two endpoints is encrypted as with the virtual private network. So that's why this is the uses of the IP security. So IP security basically used for using this IP security, we will do that. Now, internet IPsec, we say internet protocol. This internet security is what? There is the internal components. Some of components are present. Now the components, what are the components present? Now the components present is the encapsulation security payload. It is present, encapsulation security payload. Now what does this field do? There is what? There will be, we know that there will be like this encapsulation security payload present. This encapsulation security payload will do what? It provides the data integrity, encryption, authentication, and anti-replay. It also provides the authentication for the payload. Then there is authentication header. There is an authentication header. So if we say that, let's say, there is like that, it will be present, that the form will be like this, that it will be our IP header. There will be IP header present. Then authentication header. Then authentication header. And then TCP. Then TCP. Then data. So like this, it will form. Now this authentication header do what? This authentication header provides the data integrity, authentication, and anti-replay. And it does not provide the encryption. It will not provide the encryption. The anti-replay protection protects against the unauthorized transmission of packets. It will protect against the unauthorized, this anti-replay protection which is present. It will do what? It will protect against the unauthorized transmission of packets. But it does not protect data's confidentiality. Means the data, that particular data's confidentiality will not be done by this authentication header. It will only do what? It will only protect against the unauthorized transmission of packets. Only will do what? It will be unauthorized transfer of packets. It will protect against that, but it will not protect against the confidentiality of the data, against the data's confidentiality. And another thing is what? There is the IKE, that is Internet Key Exchange. Now, what is the Internet IKE? Internet Key Exchange. Now, it is what? It is a network security protocol. It is basically a network security protocol which is used to design dynamically exchange encryption keys and find a way over the security association between the two devices. So it was basically that. It is basically a network security protocol, a security protocol. Internet key exchange is basically a network security protocol, and it works as dynamically exchange encryption keys. So dynamically it will exchange encryption keys, and it will find a way. It will find a way over the security, association, between the two devices. So IK is basically Internet Key Exchange, and it is a network security protocol which designed to dynamically exchange encryption keys. Dynamically, it will exchange the encryption keys and find an answer for the over the security exchange association between two devices, because the security association establish shared security attributes between the two network entities, and it will support the secure communication. So it will do that security association. So it will find a way over the security association between the two devices. Now, what are the working of this IP security? The working of the IP security is like that. The host will check if the packet should be transmitted using IP security or not. So that means first the host will do what? It will check that the packet should be transmitted using the IP security or not. That is what, after this, the packet traffic triggers the security policy for themselves. Now, this packet traffic will only it will trigger the security policy. For the security policy which you have to use, that security policy, it will implement this security policy. In this security policy will be implemented themselves, and this will be done when the system sending the packet. And when the system will send a packet, let's say A and B, these are that the two systems present, and let's say A wants to send. So it will do what? This will be sending the packet, will be apply an appropriate encryption. The packet which is sending from, let's say, from sender A to receiver B, in this will be over that an appropriate encryption will be used, so that the incoming packets will be what? Now, if there is an appropriate encryption technique used, so that means it will be checked that the message that is sending from sender to receiver, it will check that any malicious message is going from there or not. Same thing should be applied for here also, that this is what? A is the host, because from this system we are sending packet. So apply an appropriate encryption over that packet, and also the incoming packet. That means, let's say, what are the incoming packets A is receiving? Over that incoming packet also, they will be encrypted properly or not. It is checked. It will be checked by the host. Now, A is sending the packet to B, it is applying the appropriate encryption over that. It's okay. But when the incoming packets are coming, to the host, so it will check what? It will check that the packet which it is receiving, the host is receiving, that packet are encrypted properly or not. That packet is encrypted properly or not. It will be seen by the host. Okay. And the channel created. So there will be the channel created, and last step to use it is the secure negotiation. The way then IP circuit will encrypt data across the IP circuit. So it will be C. Then after that, the internet, first these things happen. Then internet key exchange. The internet key exchange will do what? This internet key exchange starts. The first internet key phase 1 starts in which the second host authenticate themselves to each other to set a secure channel. That means, let's say when the communication will be started, in that time, the B will receive what? That A will send the intended message. Yes, the message I am sending, it is coming from intended A only. That is the authentication. Yes, you are receiving the message and I am the person who is sharing this message. So this is the authentication. So they will authenticate themselves to start the secure channel. And it has two modes. So two modes will be there. The main mode will provide the greater security, and aggressive mode. So main mode and aggressive mode are the two modes present there. So main mode will do what? It will provide the greater security, and aggressive mode will do what? Which enables the host to establish an IP security circuit more quickly. So it will enable the host to establish the internet circuit, this IP circuit, more quickly. So this aggressive mode will do that. So after that, then two systems communicate with each other. So that means they are intended receiver. That yes, I am the intended receiver and I am the intended sender. So after this, the channel is created. So when the channel will created, after that, a negotiation of this IP circuit, a negotiation of the way the IP circuit will encrypt the data across the IP circuit. So in this IP circuit, across this, the data will be encrypted. Then in the next phase, so first phase, internet key exchange, first phase, we have seen the main mode and the aggressive mode. Main modes providing the greater security, and aggressive mode doing the establishing IPsec circuit, doing the establishing the IPsec circuit. This was they are doing. Then in the second phase, so after that, in the fourth step, the internet key exchange phase 2 is conducted over the secure channel. So in this phase 2, it will conducted over the secure channel, in which two hosts negotiate the type of cryptographic algorithms to use on the session. Now they will exchange that which type of cryptography algorithms they are using. So A will use a cryptography algorithm and B will use another cryptography algorithm. Now, what are the algorithms we have seen? RSA, DSA, AES, like this the algorithms are present. So let's say A is using RSA algorithm and B is using AES, advanced encryption algorithm. So two algorithms are different. So that will be not, we will not do that. It will negotiate. So that's why they will negotiate in this secure channel that which type of algorithms they will use. And both these systems, or both the hosts that are present, will use the same cryptographic algorithm, on the session. And after this is negotiation occurred, or fixing these issues fixing these issues, then the secret key material to be used with those algorithms. So secret key material will be used for that algorithms. Then all the things are managed, that both are using the same cryptographic algorithms, and they establish the secure communication channel. All of the things have happened. Then after that, what we'll do? After that, the data is exchanged across this newly created IPsec encrypted tunnel. So that now the data will be transferred, and these packets are encrypted and decrypted by, now in both the cases, the IPsec is present in A and IPsec is also present in B. So in both, now these packets will be what? These packets will be encrypted and decrypted by the host using the IPsec session. So IPsec sessions, they will encrypt and decrypt the message. And when the communication between them, so the message transferring has been started and they are sending the message. So when it will complete, then the host will complete its session, and IPsec tunnel that is created during for the communication, this will be also terminated by discarding the keys of both hosts. So it will discard its key, session key, and it will also discard its session key. So when it will, both of them will discard, then the tunnel will get terminated and the communication channel will also be terminated. So between them, the communication will be, that communication channel will get lost. So like this, the communication, after performing the communication, they will do what? It will terminated the communication channel, because the communication is already occurred now. So that's how the IPsec, using the IPsec, we will do that. Okay, it is clear?
Yes, sir.
Yes, sir.
Okay. So like this, the communication should be happened. So this is the mention that IP protocol suite. This is the that internet key exchange protocol, that this key in internet exchange protocol for negotiating the security parameters and establish the authenticated keys, and it is using, now this will be use some port. The port number is the 500, and there is what I have already discussed, the encapsulation security payload protocol for encrypting and authentication securing data, and it will use the IP protocol 50, that is the port number. The port number 50 will be used, and for authentication header, for authentication and securing the data, this will be used the 51, port number 51, they will use it. So this is all about the IP security. Okay, so after that, this IP security, there is the VLAN concept. So VLAN already in the network, I have already in the networking, we see that how the VLAN connection, virtual LAN connection, we have discussed about that. But now also we will discuss it. But in the because in today the full VLAN concept I will not able to discuss because the time is very short. So I will start the introduction part of the VLAN, the concept of the introduction part of the VLAN. Now the VLAN is basically, it is the logical segment. It is basically the logical segment switch network based on the function. The switch network and projects team or application of organization regardless of the physical location or connection to the network. And all the workstations or the servers that is used particularly share the same VLAN. Particularly they are sharing the same VLAN regardless of the physical connection and location. So regardless of physical connection or location, all the workstation or servers that will be use the particular work group, and they will share the same VLAN. So VLAN is basically, it is used for switching network based, for switching the network based on function, application of the organization, regardless of the physical location or connection to the network. So without seeing the physical location or the connection of the network, VLAN is basically, it is switch network. It is basically the switch network that is used in the organization based on the functions and application of the organization. And this is what the workstations of the used by the particular work group will share the same VLAN. Okay. Sorry. So this is about the concept of the VLAN. Okay, so in the next class, we will see about that topic. So today, this is all about. Thank you, everyone. Okay.
Thank you, sir.
Thank you, sir.